Last time, we got the running light and turn signal working on the driver's side, but there's a lot of work to do before this car is ready to be on the road again. Got some daylight again, so time to finish up this project. Here is my custom wiring harness for the front turn signal and running light. Here is the original stock wiring harness, just sort of packaged up in some conduit. It'll be tucked in here, ready to be installed if there's ever a problem with my system. And on the passenger side, and my harness. Almost looks like it's supposed to be here. Last thing I need to do is install the daytime running light switch. Now, if you were expecting show car quality, you are on the wrong channel. The label is silver Sharpie on tape. The switch is not exactly square and not exactly centered. Deal with it. For the running lights, I could have tapped battery power from the back of the headlight switch, but I chose to take it from the battery directly through the relay because I don't want to load any of these circuits with anything more than the small 30 or so milliamps required for the relay coil. Switch is all wired up. Let's give it a test. Running light switch. Parking lights, headlights, parking lights, main switch off, daytime running light switch off. During my shakedown run, I noticed something a little bit odd. The passenger side running light was winking and flickering on and off, while the driver's side remained on constantly. The turn signal worked fine, though I was concerned somebody would mistake the white light blinking for a turn signal and misinterpret my actions. We need to get to the bottom of this. No matter what kind of wire wiggling I do or did, the light does not flicker once until I start the engine. Wink, wink. It's doing it. You notice the driver's side doesn't seem to care. Passenger side will every so often wink on and off. With the engine shut off, it will stay on constantly, possibly for hours. It doesn't seem to care. So, somewhere, I'm suspecting electrical noise. Got my multimeter hooked up to the correct pin on the connector. We're getting battery voltage, 12.37, a little bit low because there's a few things on. AC volts, seems to be something there on the AC. It's unusual, would not expect that there. However, despite the meter picking up a voltage in the AC range, it doesn't seem to pick up anything in frequency. Let's see if anything changes when the engine is running. Now we got something jumping all over the place, but it looks like between 300 and 400 hertz. Let's see what the AC voltage is. It's small, but there is something there. If this frequency is related to the engine speed, it should change when I rev it up. Well, that was unexpected. It went down when the engine speed increased. I'm not quite sure what to make of that. Now to probe it while the light is installed. 12.34 volts DC. Now we're down into just millivolts of AC, so installing the bulb helped with that. Maybe it was noise the open-ended wires were picking up. We go over here to frequency, and likewise it shows nothing. Time to start the engine. There's that AC frequency. See if there's any correlation between it and the bulb. Not that I can see, but it is present. Doesn't seem to be a whole lot of noise on the turn signal wire, but there is a weird frequency of AC noise there. Let's see if this changes when I rev the engine. Hey, now we're getting somewhere. stuck a pair of film caps I had lying around between the ground wire and the turn signal wire. It's only about 15 nanofarad, but if it solves the problem, I will be happy. When in doubt, use a bigger capacitor. Watch what happens to the frequency on the meter when I hook this up. It freezes, and it goes to 0. I think I might have found my solution. However, it also seems to have an odd effect on the flashing rate. Look at how it stays mostly on with only a tiny dip off, but if I disconnect the capacitor, it goes back to standard hyperflashing. A smaller 470 microfarad capacitor seems to suppress the noise, but the turn signal behaves a little more predictably. Got the capacitor wrapped up in heat shrink and soldered between the negative and the turn signal power leads. When I apply power to the turn signal only, it'll flash on and off, on and off. That's pretty standard. But watch what happens when I apply constant power to the running light side and touch the turn signal lead to give it power. It stays amber for several seconds before going back to running lights. Let's watch what the voltage does. Slowly decaying. It looks like around 4 volts is the threshold. If it's above that, it's amber, and if it's below that, amber goes out and the white running light comes back on. Yep, around 4 volts. Adding a resistor in parallel should bring the timing back into an acceptable range. There's that. Yep, that's more reasonable. There we are. Resistors and capacitor packaged up with the connector, ready to go back on the car. Now let's see both of them working together.